Okay, next speaker is going to take us into space. So take it ahead, folks.
Thanks a lot. And I think I might need to disappoint nearly everybody. We are not really talking about running OVN in space. If we would ever do that, I'm quite sure we would do a talk here. This talk is more about building a cloud management system using OVN Concepts. And basically, why is probably the first question. It's mostly we are currently running on OpenStack Neutron, and it has some opinions on how things should work, and we have other opinions on how things should work. And right now, the plan is to have some kind of both worlds at the same time at the moment. We have some users that, for example, need things like policy-based routing across multiple networks and multiple routers that are connected to each other. And building that into Neutron upstream sounded a lot harder than building something on your own. Maybe we will actually replace Neutron with this completely because it worked so well and was so much easier to maintain than all the Neutron stuff. Just to have a quick look at what weirdness of policy-based routing people wanted to do on our side. Basically, we have a thing called a network area, which includes a lot of different logical switches and logical routers connected all together. And we allow people on each logical switch to define a routing table where they can define where do they want to send traffic for given IP addresses. They might go to other networks directly. We might rewrite traffic for specific /32s and things like that. Just to, for example, allow people to place weird firewalls and paths or IPS systems or whatever else people might desire. So how are we going to do that? We have a lot of Golang in our existing system, so we wanted to keep in that language, and we didn't want to scare everybody with C. But we also wanted to stick to OVN concepts. So the idea was that we build a custom OVSDB schema that we put basically on top of Northbound that acts as our basically CMS constructs. And since it's on top of Northbound, it's obviously in space, and we named it Spacebound. And below that, there's then a translation layer, which then needs to be named SpaceD, which is using from OVN Kubernetes the libovsdb to talk to the Spacebound database, read data from it, run it through something that's similar to the incremental processing engine of Northd, and then write it to the Northbound database. And since Neutron also writes to the Northbound database and really likes to keep its resources in there and really likes to delete everything that is not managed by Neutron, our idea was to just say these tables are owned by Neutron, these tables are owned by us, and let's try to not interfere too much with each other. And just to like graphicalize how the name of Spacebound came to be. Yeah, challenges, it really worked quite well, honestly. Most of the challenges we had with libovsdb and using or misusing that for our use case. libovsdb seems to be a lot more event-driven than what's, for example, done in Northd with having like a full reconcile of a lot of resources in a consistent way without like intermediary changes that come in from the database. So we hacked in a bunch of things to prevent updates while we reconcile and then resume them afterwards. And things that is quite nice in Northd when actually like inserting things like resolving references. If you insert, for example, a logical router policy and then reference that in a logical router in Northd, or so you can do that quite easily by just assigning that resource. For libovsdb, you actually need to play with UUIDs that you need to fake assign in before. So that's a little nicer. And incremental change tracking is, at least from what we know, not existent. You can subscribe to the events, but you don't like have this batch of changes that you want to work on. And so our idea on how to improve that in the longer run and to actually get like these incremental processing in there is to actually use the clip open vSwitch and build a Golang wrapper around it, and then try to use this to get the data from the spacebound database, map it to structures in Golang, and actually also get change lists of which rows changed, which columns changed in these rows, so that we can actually implement incremental processing. Because if we want to move all resources on that, then I don't see it any other valid thing. And also to get rid of Neutron more and move more things to it. And since this should be a short talk, it is a short talk, and I'm happy to take questions.
Is it available anywhere to look at, or is it internal?
It is internal, mostly because the idea was to map structures we want to give out to our customers from there to OVN. So unless you want to have the same structures in your environment, it doesn't make too much sense. And therefore, I'm also not sure how much value it is. If we would do the lib open vSwitch wrapping to Go, that was an idea to open source.
You had a slide sometime back that showed some layering, like, yeah, that one. Okay, I have a question. Why vSwitch-D is on fire?
I mean, if you ask probably a random IT person on what's the most scary thing of OVS and OVN, I would definitely assume packet processing, because people are scared of IP addresses anyway. So,
what functionality you plan to move from Neutron to your space, and why?
probably in the long run, all the things. We have people that want to have, for example, deny rules for security groups in Neutron. Neutron doesn't support that because there's actually no reason to that. There's an implicit deny in the end. But there seems to be like regulations that people go to jail if you talk to certain countries. So I can understand why they want to have a very explicit deny statement there. And things like these will like cause us to move certain features to the space feature. And at some point, I guess there's not so much in Neutron left that it's worth to maintain it anymore.
So it seems like you are heading in the same direction with the incremental processing as OVN is right now. Have you considered like any other way to do incremental processing? Like, speaking from experience, it can be really tricky, really quick.
No, not yet. But maybe if somebody has an idea, we're probably happy to take it.
Okay.
If I understand correctly, like you don't have the incremental processing with the libovsdb right now, right?
Mm-hmm.
Okay. So if we move to go open vSwitch approach, which you said, you think it's possible for us? I'm just a thought that OVN North could be done the same way if it makes it much more cleaner for the incremental processing to be handled.
So I did some testing for that, and it seems also, while wrapping it in Go, that seems to be doable. Just building this nice abstraction on top of it is necessary. Otherwise, it works quite well.
I guess my question was similar to Numan's. I was wondering if it turns out that the incremental processing with libovsdb is nicer, would you consider prototyping OVN North in Go?
I guess that's a lot of things that would need to be moved there, but it's something that could be tried out. I mean, depending on how it's done, if it's using the Go binding for lib open vSwitch, then maybe it can even do it with FFI magic and without too much changes. If you go for the libovsdb and build it to that features, then I guess you need to change a lot of things at the same time.
Yeah, I guess. Okay.
There is one question line. What difficulties did you run into with upstream neutron that made you move to a bespoke?
Answer.
What difficulties did you run into with upstream neutron that made you move to a bespoke?
It's currently for what we have. It's a lot of performance things, but also we have a lot of requirements feature-wise that just don't match what I think is valid also for Neutron as open source, as an open source project. And especially these deny security group things. I totally understand why Neutron doesn't want to have them because they don't make sense. I also understand why our users want to have them because they go to jail otherwise. So we have some trade-off to make there. That seemed like the easiest to take.
Okay, let's thank our speaker.